Okay, I'm doing problem number 12 on Unit 7 of E&M. So number 12 says, recall the flux of the electric field was given by this formula, where the integral is evaluated over the entire area of interest. Similarly, the flux of the magnetic field is this. The long straight wire AB in the sketch at the right carries a current I. So A, what is the magnetic field at the shaded area at the perpendicular distance x from the wire? So what we're going to do is use the formula that we derived on the top of page 7, which is BP equals mu times I over 2 pi d, and in this case d equals x because it's x away from the wire. Here, this distance is x, and we're just going to plug that in, so you get BP equals mu I over 2 pi x, which is the answer. So part B says, what is the magnetic flux through the shaded area? So this shaded area, what is the magnetic flux through that area? So, we're going to use the formula they gave us, which is flux equals the integral of B dot dA. And for B, we're just going to use what we found in part A, which is mu times I over 2 pi x, and for dA, we're going to use the area of that section. So if you look at the picture, the width, I guess, is dx, and the height is L. So area is just dx times L, which is what we have here, dx times L. And then we're just going to plug that in, and we get that the flux is the integral of mu I over 2 pi x times dxl. And that's the answer. Part C, what is the magnetic flux through the entire rectangular area CDEF in terms of I, L, A, and B? So what is the flux through this whole rectangle here? So for this, we're going to use the formula that we found in part B, and we're just going to integrate it from A to B, because that is this distance. So we want this, basically this tiny area from here to here. So it's this whole thing is basically how that's going to work. So we just integrate from A to B, and you get, if you pull all your constants out front, you get mu times I times L over 2 pi, integral of A to B of dx over x, and this is the easy part. You just, all your constants times ln x from A to B, and that gives you mu times I times L over 2 pi times ln of B over A, because ln of B minus ln of A equals ln of B over A.